Hello everyone, welcome of all you to this online platform. So let's start our class. Today in this class I am going to start a new chapter number 1, sets. First we will discuss what is sets. Remember, set is a well-defined and well-distinguished collection of objects. So write definition of a set. A well-defined and well-distinguished collection of objects is called a set. In general, we represent sets with capital letter all elements of a set will be written in curly bracket and should be written only once. What is set? A set is a well-defined and well-distinguished collection of objects is called a set. In general, we represent sets with the capital letters A, B, C, etc. A, capital A, capital B, capital C, etc. All the elements of the set will be written in curly bracket and should be written only once. For example, the collection of all students in your class. For example, the collection of all students in your class or collection of natural number, all natural numbers. For example, number 1, the collection of all students in your class. Number 2, the collection all natural number less than 100. For example, the collection of all students in your class and the collection of all natural numbers which is less than 100, these are called sets. Now we take another example. The collection of 5 good students in your class in your class. For example, the collection of 5 good students in your class, this is not a set because the good students in your class are not well defined and not well distinguished. Therefore, this is not a set. Next, symbol belongs to and not belongs to. Remember, if X is an element or member of a set A, if X is a member or elements of the set A, then we can write X belongs to A. Then if X is a member or elements of the set A, then we can write X belongs to A. If X is not a member, or element of the set A, then we can write X not belongs to A. If X is a member of the set A, then we can write X belongs to A. If X is not a member of the set A, then we can write X not belongs to A. For example, A is a set 1, 2, 3, 4. Here, the element 2 belongs to A. The element 2 belongs to A. Therefore, we can write 2 belongs to A. Here, the element 5 is not belongs to A. The element 5, the number 5 is not belongs to A. Therefore, we can write 5 is not belongs to A. Or 3 is belongs to A. The number 3 is belongs to A. Therefore, we can write 3 belongs to A. But the number 7 is not belongs to A. Therefore, we can write 7 does not belongs to A. Next, we will discuss how to represent a set. How to represent a set. Representation of sets. Representation of sets. There are 2 forms represent a set. Number 1, set builder roster form or set builder form. Oh no, sorry, tabular form. Number 2, set builder form. There are 2 forms to represent a set. Number 1, roster form or tabular form. Number 2, set builder form. First, we will discuss the number 1, roster form. How to represent a set by using roster form. Number 1, roster form. In this form, a set is described by listing its elements separated by commas within bracket curly bracket. In this form, a set is described by listing its elements separated by commas within curly bracket. For example, the set of first 5 natural number, then we can write, for example, A is a set, the set of 5 natural number, the first 5 natural number, the first 5 natural numbers are 1, 2, 3, 4, 5. Therefore, we can write A is a set 1, 2, 3, 4, 5. Elements separated by commas and within curly bracket. This form is called roster form or tabular form. The set of natural number which is less than 6, but the set of first 5 natural numbers, A is equal to 1, 2, 3, 4, 5. Next, we will discuss set builder form. Number 2, set builder form. Set builder form. In this form, instead of listing all the elements of a set, we describe the set by some special property properties satisfied by all of its elements and written and write it as A is equal to X. This symbol stands to such that therefore curly bracket start X such that P of X holds equal to X such that X has the property P of X. And what is set builder form? In this form, instead of listing all of the elements of a set, we describe the set by some special property. We describe the sum of some special property satisfied by all its elements and write it as A equal this. We mention some special properties which satisfy all of its elements. In this property, we mention some special property which is satisfied by all its elements. For example, remember, these and these symbols are same. This tends to such that this stand to such that. For example, if set A is equal to 1, 2, 3, 4. A is a set of the elements 1, 2, 3, 4. Then it can be written in the set builder form. In the set builder form as if A is a set of the elements 1, 2, 3, 4, then it can be written in the set builder form as A is equal to X such that we mentioned some special properties. X such that X belongs to AND, capital AND means natural number. X such that this symbol stands to such that X belongs to N is a natural number, and X less than 5. The natural number less than 5. X such that X belongs to N and X less than 5. This process is called set builder form. X such that X belongs to N and X less than 5. Therefore, the elements are 1, 2, 3, 4. Now, we will discuss different types of sets. Different types of sets. Types of sets. Number 1, empty set or null set. Empty set or null set. Empty set or null set. Remember, a set which has no elements, this set is called the null set or empty set or void sets. Which has no elements of this sets, then that set is called the null set or empty set. For example, the set of natural number which is less than 1. The set of natural number which is less than 1. For example, A is a set X such that X belongs to N and X less than 1. This is a null set because there are no elements which is less than, there is no natural number which is less than 1. Therefore, this set is called a null set. A set has no elements of this set, then that set is called the null set or void set. Next, we will discuss singleton set. Number 2, singleton set. Singleton set. A set having only one element. If a set having only one element is called a singleton set. A set having only one element is called a singleton set. For example, the set of prime even number. The set of prime even number. This equal to, we know that only one element, so only one number, that's which is prime and event, which is equal to 2. Therefore, this set is called a singleton set. For example, the set of prime even number. And another example, X such that X belongs to N and X less than 2. There are only one element which is equal to 1. X is a natural number which is less than 2. There are only one element, which is the natural number less than 2 is equal to 1. This equal to 1. This set is called a singleton set. Next, cardinal number. Next, number 3, cardinal number. Cardinal number. The total number of elements of a set is called a cardinal number. What is cardinal number? The total number of elements of a set is called a cardinal number, and it is denoted by, if A is a set, then it is denoted by n of A. If A is a set, then the cardinal number of the set A is denoted by n of A. For example, A is a set 1, 2, 3. The cardinal number of set A is equal to, and is denoted by P of A, is equal to 3, because here the total number of elements 3. Therefore, the cardinal number of the set A is equal to 3. We take another example. B is a set of element A comma B. Therefore, the cardinal number of this set n of B is equal to 2, because here the total number of elements is 2. Therefore, the cardinal number of these elements is equal to 2. Therefore, n of B equal to 2. Next, finite or infinite set number 4. Finite or infinite set. Infinite. Finite or infinite set. What is finite or what is finite? Finite set. Finite and infinite set. What is finite and infinite set? A set which has finite number of elements. A set which has finite number of elements. That set is called the finite set, which has finite number of elements. For example, A is a set of the elements x such that x belongs to n. N is a natural number and x less than 100. X less than 100. There are 100 total number of elements 100. Here the total number of the elements of set A is 100, because x belongs to n and x less than their total number of elements is equal to 99, because x less than 100. Here the total number of elements is 99, because the total number of elements is finite. Therefore, this set is called a finite set. What is finite set? A set is called a finite set if the total number of elements are finite. Otherwise, it is infinite. If the total number of elements are infinite, then that set is called a infinite set. For example, the set of the natural number. For example, the set of the natural number. N is denoted by capital N. The set of the natural number. The set of natural number. X such that x belongs to n and x greater than 10. For example, x such that x belongs to x is a natural number and x greater than 10. There are finite number of elements, for example 11, 12, 13, 14 to infinity. Therefore, this set is called infinite set. What is infinite set? If the total number of elements of that set are infinite, then that set is called the infinite set. Next, number 4. Next, number 5. Universal set. Number 5. Universal set. Universal set. A set containing all the possible elements. A set containing all the possible elements is called as universal set. A set containing all the possible elements is called as universal set, and it is denoted by capital U or mu. And is denoted by capital U or mu. The universal is denoted by capital U or mu. Next, equal set. Number 6. Equal sets. If let n be two sets, or if A and B are two sets, two sets, or let A and B are two sets if the elements, the corresponding elements, but the elements, they have the exactly one same elements. If they have the exactly same elements, that set is called, these sets are called equal sets, right? Two sets A and B, are said to be equal, said to be equal if they have exactly same elements, Two sets A and B are said to be equal if they have exactly same elements. For example, A is a set, for example 1, 2, 3, and another set B, which elements are 2, 3, 1. The elements of the set A are 1, 2, 3. 1, 2, 3. The elements of the set B are same, 1, 2, 3, or 2, 2, 3, 1. The elements are exactly same. The set A and set B, the elements are exactly same. Therefore, the set A and B are equal. Then we can write, but we can say the set A and B are equal, and it is denoted by A equal to B. Next, number 7. Equivalent set. Number 7. Equivalent sets. Equivalent set. What is equivalent set? If two sets A and B, if let A and B are two sets, let A and B are two sets. If the total number of set A is equal to the total elements of the set A is equal to the total number elements of the set B, then the two sets are called equivalent set. If the total number of the element of the set A is equal to the total number of the element of the set B, then the two sets are called equivalent set. For example, A is a set 1, 2, 3, and B is a set 2, A, B, C, A, B, 3 or C. Here n of A, the total number of the set A is equal to 3, or the cardinal number of the set A is equal to 3, and the cardinal number of the set B, n of B, equal to 3. Therefore, the n of A is equal to n of B. The total number of the element of the set A is equal to the total number of the element of the set B. Therefore, the set A and B are called equivalent set, and it is denoted by A equivalent to set B. The set A is equivalent to the set B. Next, subset or superset. Number 8. Subset and superset. Subset and superset. The set B is said to be subset of a subset of set A if every element of set B, if every element of set B is also an element of set A. The set B is said to be subset of the set A. The set B is said to be subset of the set A if every element of the set B is also an element of the set A, and it is denoted by every element of the set B is also the element of the set A and is denoted by B subset of A. B subset B, it is B subset of the set A, and then A is called the superset. If B is subset of A, then A is called the superset. If every element of the set B is also the element of the set A, then B is called the subset of the set A, and it is written as B subset A. Then A is called the superset of the set B. Next, we will discuss power set. Sorry. Next, number 9, proper subset. Proper subset. The set B is said to be a proper subset, of set A if every element of set B is an element of A, whereas every element of A is not an element of B. Proper subset. A set B is said to be a proper subset of set A if every element of set B is an element of A, whereas every element of A is not an element of B, and it is denoted by P is proper subset of A. Then A is called a proper superset. Every element B is said to be proper subset of the set B if every element of the set B is an element of the set A, whereas every element of A is not an element of the set B. For example, B is a set 1, 2, 3, and under set A is element 1, 2, 3, 4, 5. Here, the every element of set B, every element 1, 2, 3 is the element of the set A 1, 2, 3. But every element of set B, for example 4, 5, is not an element of the set A. Here, the every element of the set B is an element of the set A, but every element of the set A is not an element of the set B. Therefore, B is called the proper subset of A, and A is called the proper superset of A. Next, power set. Number 10, power set. Power set. The set form by by all the subset of the given set A by all the subsets of a given set A is called the power set of A. It is denoted by P of A. What is power set? A set formed by all the subset of the given set A. The set formed by all the subset of the set A is called a power set of A, and it is denoted by P of A. For example, A is a set 1, 2, 3. Then P of A, the set of then P of A is equal to all the subset of the set A. All the subset here, the subset phi 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. For example, A is a set, then the power set of A is equal to this. Next, remember some important points. Some results on subset. Remember some results on subsets. Number 1, every set is a subset of itself. Every set is subset of itself. The first point, every set is a subset of itself. For example, A is a set 1, 2. Therefore, A is a subset of the set A. We can write A subset A. A is a subset of the set A. Every set is a subset of itself. Number 2, the point 2, the empty set is a subset of every set. Remember, the empty set or void set or null set is a subset of every set. We know that the empty set is denoted by phi. Therefore, phi, the empty set is a subset of every set. We know that the empty set is denoted by the symbol phi. Therefore, phi is a subset of every set. Number 3, the last point, the total number of the subset, the total number of subset of finite set containing n elements is 2 to the power n. The total number of subset of finite set containing n elements is 2 to the power n. For example, here the total number of these elements, the total number of elements of this set are 2. Therefore, the total subset of this set is equal to 2 to the power 2. This is equal to 4. The total number of subset of this set is equal to 4. We take another example. A is a set. The elements are 1, 2, 3. Here the total number of elements 3. Therefore, the total subset of this set is equal to 2 to the power n. Here n is equal to 3. Therefore, the total number of subset of this set is equal to 8. Thank you.